everybody, welcome to Coding Challenge number 3 with the C2 Pipeline Innovation and Curiosity Center. If you don't know me already, I'm Mikayla, and today we're going to be working with a programming language called Ruby. We're going to be working with Ruby through a compiler called Sonic Pi. Now, Sonic Pi can be used on any computer, so it doesn't matter if you have a Mac or a PC, or you have a Raspberry Pi you want to download it onto. We're going to be talking about that today. If you haven't already, go ahead and watch the Raspberry Pi introductory video. That'll give you a little bit more in-depth background on what we're going to be doing today. But today we're going to be working on composing a song, or transposing a song actually, from a sheet of music. So that being said, let's get started. Alright, so let's take a look at our challenge for today. So our challenge prompt is asking us to transpose the song Mary Had a Little Lamb using the Ruby programming language. So to do that, we're going to have to download the Sonic Pi compiler, and we're also going to have to utilize the use of the play and rest functions in our program. So again, if you haven't watched the introductory video, you might want to do that just to get a feel for how Raspberry Pi works. But other than that, let's get started. Okay, so our first step this week is going to be to download the compiler we're going to be using. It's a little bit different than last week because we're going to be using a compiler that we download instead of using an online compiler. So to get to the compiler, you have to go to Google and search Sonic Pi. Now it should be this very first link that pops up, this sonicpi.net right here. So once you go ahead and click on that, it'll launch this page. And all you have to do is scroll down, and there's 3 buttons you can click to download it. So you have to look at the system that you're running. So you can download Windows or Mac, which is an Apple computer, or if you have a Raspberry Pi, you can download it on there too. So go ahead and click whatever device you have. I have a Windows, so once you click on that, it should open this. Now there's 2 different versions you can download. One is a portable, and the other one's an installer. So the portable app is for if you want to download it on a flash drive and plug it into other computers and run it kind of like you would a game and a game cartridge. The other one is for your hard drive, so it's just automatically on your computer. I think I have the MSI installer version, but it really makes no difference in what one you choose. It just stores it a little bit differently on your computer. So once you download it, I already downloaded it, so once you download it, you can launch it and you should have this screen. So now we're going to pause for a minute while you guys work to get your compilers all lined up. So now that you have your compilers all set up, we have to find the sheet music that we're going to be using to read off of in order to transpose the music on the paper to music in the computer. So all I did was Google image search Mary Had a Little Lamb sheet music up here, and there's a ton of different options. Now I'm going to use this one just because I like the size of the screen and like all that kind of stuff. So once you get this, you can go ahead and download it or maybe print it out, whatever you want to do, and we can go from there transposing the music. Alright, so what I've done now is I've taken this same picture that we found online, so if you recognize this right here, it's the exact same, and all I've done is put it into a Word document so we can mark it up and kind of pseudocode our way through the music if you've never read music before. What I've also done is I've added up here, I've added a scale of notes all the way up the staff. It's not all the notes that is in a treble clef, but it's a majority of them that we'll need for this program. So just a little bit of terminology here before we get started. This right here is called the staff, and it's where the note sits. It's really important to pay attention to each of the lines in the staff once we get into the reading process. These right here are notes, of course, and we'll learn a little bit more about notes later in their values in a few minutes. This right here is called the treble clef, and it's just going to tell us what octaves we're going to be in, but it's really important that you actually choose a sheet of music that has this clef, or else it'll be kind of hard to follow the video, and especially when we get into the coding process, it's kind of tricky to transpose the bass clef into the MIDI table that we're going to be using. But nonetheless, if you have this, don't worry about it because you're on the right track. So our first thing here is going to look at the pitch of the notes that we're going to be doing. So each one of these letters is a different pitch. So looking at this first note here, we have a note that's sitting on the very bottom line of the staff. So the line that's sitting on the note that's sitting on the very bottom line of the staff is an E. So let's go ahead and write that E underneath that note, just so we know later on that that note's an E. Now moving on, we're heading downwards, and we have a note that's sitting underneath the staff, okay? So now we go up to our little scale here, and we're like, okay, where's the note that's sitting underneath the staff? Well, that would be this note right here. So we know that that note's going to be a D. Now moving on, we see that we have a note that's sitting way underneath the staff, maybe one step. It's exactly one step actually, and it's sitting on the first ledger line. So this line that the note is sitting on is called a ledger line. So this note is going to be a C. And then moving on to our next note, we have, going back up the scale, we have it sitting right underneath, and as you can see, it's the same as this note right here. So it's actually gonna be another D. And so we got the first measure done. So this series of 4 notes separated by a bar right here is called a measure. So now we can move on to the second measure, and we have this note right here, and you can see that it's the same as this first measure, and up here, if you go back up to your table, it's sitting on that bottom ledger line. So, or not ledger line, sorry, the staff, the bottom line of the staff, and you can see that it's another E. And if you look to the next note, it's the same exact note, so it's an E again. And don't be alarmed here when you get here, because there's no filling. It's just a different type of value for the note. So this is the exact same note, it's just held for a different length. So there's our second measure. Now moving on to our third measure, we have a note that's sitting underneath the bottom line of the staff. So we know that that's going to be a D. And you continue on this path all the way through the entire song. So we're going to pause here while you go ahead and work on that. Okay, so now what I've done is I've gone ahead and put all the note pitches underneath each of the note, which is something that you should have done in the last step. So now that that's done, I've taken another image off of Google, this one up here, and I've put it into the Word document. So what this does, this chart is showing, is the breakdown of notes. So everything starts with a whole note, and a whole note lasts the whole length, like the whole duration of a measure. So if we have 4/4, which is the time signature we're in now, a whole note will last 4 counts. But that's besides the point right now, because we have to put it into decimals for the computer that we're going to be working with. So moving on, we split the whole note in half. As you can see, we split it in half every time. So a whole note divided by 2 gives you a half note. And you see we divide the half note in half again. And if you divide a half in half, you get a quarter. And if you divide a quarter in half, you get a eighth note. And you can keep going on and on and on and keep dividing all the notes, the subnotes, in half. So the next one would be a 16th, and then it would be a 32nd, and so on. So now when we look at this, what we're doing is we have to figure out the values to input into the computer. So we're looking at this, and a whole note is equal to 1. So that's 4/4, because we have 4 counts in a measure, right? So we know that this is going to be equal to 1 because 4/4 is a whole number, it's 1. So now if we look at a half note, remember we're dividing every time by 2. So if we have a half note, so we have our 4/4, and we're dividing by 2, To divide a fraction, you have to keep the first one the way it is, flip the second one, and change the multiplication. So remember, you're multiplying straight across the top and straight across the bottom. So we're left with 4 over 8, which is the same as 1/2. Now if you're good with decimals, the equivalent of decimals is 0.5. So that's going to be the length of our half note. So maybe let's just keep a running list over here, just because that's going to get a little bit messy over there. And we'll write the picture of the whole note, and we know that a whole note is equal to 1. And then we have a half note, and a half note would be this, and it's equal to 0.5. So now moving on to a quarter, we know that it would be the half note, so the 1/2, and it's divided by 2 again. So we have the half note divided by 2, so you have the 1/2 times 1/2, because remember, we're keeping that first fraction, flipping the second one, and changing the multiplication. So we're going to have multiply up straight across the top. We're going to have 1/4. So now that that 1/4 is there, if you're good with decimals, again, if not, you can plug it into your calculator. We're going to have 0.25. So we have a quarter note, which is equivalent to this, equals 0.25. And then finally we have our eighth note. So we're taking, remember, this quarter note from above here, and we're dividing it by 2 again, which is the same as 1/4 times, remember, because you're keeping the first one, flipping the second one, and changing the sign of multiplication. So it's the same as 1/8. So that is going to be the equivalent of 0.125. So let's go update our table over here. And an eighth note has that cute little tail, so it's like this note right here. Now these are the values right here that you're going to be plugging into the computer. Alright, so now that we have all of our notes and values assigned to them, we're going to actually put the values to the notes in the sum. So let's look at our first measure here. So we have, starting with the first note, we have a quarter note. So that's going to be worth 0.25, right? What we figured out up here. So now we go on to the second note, and that's also a quarter note. The third note is also a quarter note, and the fourth note is also a quarter note. Keep in mind that all these things should add up to 1. Every single measure should add up to 1. Remember that this is a measure, right? So now that we have this added up to 1, we can move on to the second measure. We have 0.25 again, 0.25 again, and then we move on to the third note. Don't freak out, there's only three notes, because this note is equal to 0.5. So this 0.25 plus 0.25 plus 0.5 also equals 1. So you're going to keep going on throughout the entire song. And then there are some things I want to point out to you before you pause for a minute. Is this right here is called a rest. So what this is doing is it's actually a quarter rest. So this is going to be worth 0.25. So we know that this note's worth 0.25 as well, because it's a quarter note. And we know that this half note is worth 0.5. So when we add all these up, even though this rest isn't a note, the value of the measure still equals 1. So we're good there. Another thing I want to point out to you is if you have a dot in your program, then that dot is equal to half of the value of the note. So we know that that quarter note is worth 0.25. So if we divide that by 2, that's half, so it's 0.125. And then we add that original value to the note, then we're left with 0.375. And if we look at this is an eighth note, so we add the 0.125, and then we have another quarter, so 0.25 and 0.25. And so when you add all these up, you get 1. Now just keep in mind, you can check every measure as you go. Everything should just equal 1. So everything in between each of these bars should equal 1. And if you get that every single time, then you're doing something right. So go ahead and pause here while you finish that up. So in order to code in the program, we can't actually input the letter name of the note. We have to use the MIDI table and transpose them into numbers that the computer can recognize. So if you look at the table that's up on the screen right now, it goes in octaves. Well, the octave that we're going to be working out of is the 3rd octave, and that's where all of our notes that we've transposed from our song are going to be. So if you can see, the C starts at 60 and then it goes up from there. So then our D would be 62 and our E would be 64. So that C is going to be our bottom ledger line C, all the way up to however high you want to go to. But we're going to stay within this 3rd octave, and I believe we don't even go above 64. I think the only notes we use are 60, 62, and 64. So keep that in mind when we move into the next portion of the project. Alright, so now we should have everything pretty much done in our Word document or on your scrap piece of paper, depending on where you put it. So all your note values should be in there, as well as the pitches of the note. So now we can go ahead and put that information in the compiler. And so what we were doing actually is we were figuring out the parameters in which to input into the functions into the program. So what that means is, to play a note in Sonic Pi, you need to use the keyword play. Now, play will tell the computer to play a note, but you have to tell the computer what note to play. So using the MIDI table, you can choose a number that corresponds to a note. So our first note is E, and the note that corresponds to E is 64. So when we play 64, we can run the program, but first we need to tell the computer or the program how long to play that note. So then we have to use the sleep function, and using that time we figured out before, because it's a quarter note, we're going to put it in 0.25. And we're going to keep doing this again and again for every note in the measure. So moving on to D, we're going to use the play function, and the number that corresponds to D is a 62. So when we play 62, we need to then it needs to then have a sleep function that goes with it. So you can sleep it for 0.25, same as before. And moving on, we're going to play a C. So 60, and then we're going to sleep that for 0.25 because that's a quarter note as well. And then we're going to finally have another D, and programmers copy code all the time from inside their program. So if you already wrote code, you don't have to rewrite it again. So we already had a quarter note that was a D and played for 0.25. So we can go ahead and copy that note from before our program and paste that in there. So now we have measure 1, and you can write a comment to denote that, just so you have track of everything. And when you play the function, it'll play those 3 notes. So now move on to measure 2. And you can denote that by a comment, measure 2. And so now we're playing 3 E's. So play, and then another quarter note, or actually we're starting with a D. So play 62, and then sleep 0.25, and then we have the same note again, so just copy and paste that, and then we have play 62, but this time instead of sleeping for 0.25, it sleeps for 0.5. And remember, all these values that are in each of the measures should add up to 1. So as long as they're adding up to 1, you're doing something right. So now when we play this code and run it again, it'll show in the corner every execution of the note. So keep doing this all the way to the end of the song, and by the end you should have a fully functioning song to listen to. So now we should have all of the functions and everything coded to match the music. So if you haven't already, go ahead and click run, and it should sound a lot like the song. So some stuff to point out real quick. If you weren't sure on how to code the rest, I commented it out somewhere in here. Let's see. So what I did was I used the play 0 function. So 0 is such a low frequency that it's not going to be able to be heard. And then I set it for the length of the duration of the rest, the sleep value. So it sounds like there's a rest there. It's actually just playing a really low note that we aren't able to hear. So if you're wondering how to do that, there's that step. Another thing that you can play around with too is some different functions in Sonic Pi that you can use. So the first one would be using beats per minute. So this is setting the tempo of the song, so how fast the song is going to play. So you can set it to 120, you can set it to 100, you can set it to 80, and you can just play around with that. Another thing that you can change is the instrument that it's using. So the synth. So you're going to use the line use synth, and then followed by a colon, and then you can choose any of these different instruments to listen to. So even if you just choose a piano, it'll sound different when you run the code. So you can hit run. So you get the point. And then if you change this, so if you change it way down, so let's say 30 beats per minute. You'll see a complete change in how the song is heard. So I encourage you to play along with that. If you want to do some more like fun stuff with your code, you can add like percussion and all that kind of cool stuff. And you can learn more about that in our Sonic Pi tutorial, which is linked to this video. That brings us to the end of coding challenge number 3. As always, if you need a little bit extra information or you want to see the code fully written out, you can visit the STEM Labs website. In addition, there are tutorials on Sonic Pi if you want to go more in depth with what the program can do. Thanks for watching. I'm Mikayla from the C2 Pipeline Innovation and Curiosity Center. We'll see you next week.